Okay, today we're going to do lesson 5 of chapter 11, the distance formula on the coordinate plane and how we can use this in proofs. After you watch the video, please do the problems on page 679, problems 1 through 7. Okay, what is the distance formula? So the first thing I want to show you is how the distance formula was derived. It is based on the Pythagorean theorem. So here's a problem that we can look at and we can figure out how the Pythagorean theorem helps us with the distance formula. We have we have Sierra's house down here, and Juan's house is 3 miles east and 5 miles north of Sierra's house. In the book they talk us about something called taxicab distance, and by taxicab distance what they mean is they mean that the distance that you would drive if you had to drive on the road. So if these are streets, you would have to drive 3 miles this way and then 5 miles this way. So you'd have to drive a total of 8 miles. And that's what they're talking about whenever they mention taxicab distance. The other distance is called the bird flying distance. Now the bird flying distance is the distance that goes directly from Juan's house to Sierra's house. So it would be, in our case, if you look at this, we've made a right triangle. So what we're looking at is the bird flying distance is the hypotenuse of a right triangle. So we notice that we have 3 this way, we have 5 this way. We know how to use the Pythagorean theorem to find the distance, or the straight flying distance, from Sierra to Juan's house. But let's use that for a minute here and look at how they came up with the distance formula that we're going to use. We know that the Pythagorean theorem is a squared plus b squared equals c squared, or in the case of our example, it's 3 squared plus 9 squared is going to give us the square root of that is going to give us a direct distance from Sierra's to Juan's house. In our example, the horizontal distance, we're subtracting the x's, 3 minus 0. The vertical distance, we're subtracting the y's, 5 minus 0. Now, if we put these expressions into the Pythagorean theorem, we're going to see, okay, 3 minus 0 squared plus 5 minus 0 squared equals c squared. We also know that with the Pythagorean theorem, once we get this answer right here, we have to square root it. So we know the square root of this is what the distance c is going to be. So that's how the distance formula on the coordinate plane was derived. In this case, c is approximately 5.8 miles. So the taxicab distance was 8 miles, but the bird flying distance is about 5 8/10 miles. So this is the distance formula in a more general terms. We subtract our 2 x's and square it. We subtract our 2 y coordinates and square it, and then we square root it. If we're looking at this example down here at the bottom, what we're looking at is, okay, so I'm going to put in the numbers. So I'm going to subtract the 2 x's. So in this blank, I would put in negative 15. In this blank, because I'm subtracting my x's, I'd put in the negative 5. Okay, over here, in this blank, I would be putting in the 24, and in this blank, I'd be putting in the 7. So then I do those calculations. Negative 15 subtract negative 5 is going to give me 10. So right here, we'd put in the 10. 24 minus 7 is going to give me 17. So if you look down here, I've squared 10 and I've squared 17. I've added it together to get 389. If you square root 389, you get approximately 19.7. So the distance between these 2 points on the coordinate plane is about 19 7/10. Notice that there's no units on here. It would depend upon the size of the units in your coordinate plane, what the units would be. Okay, so let's look at another example. This one says to get the hospital from the middle of a nearby town, you can drive 7 miles east, turn right, and go 12 miles south. So let's do that using our coordinate plane. Let's go 7 miles to the east. So 1, 2, 3, 4, 5, 6, 7 miles east. Okay, then I'm going to go 12 miles south. That's 10. I would go 2 more, so 12 miles south. And then I'm going to go back 2 miles west. So here I am right about here. Now, taxi cab distance, 7 plus 12 is 19. 19 and 2, it would be 21 miles. But what if, instead of having to go on the street, I could fly in a helicopter? I would be going from here down to here. So this coordinate is, of course, 0, 0. And this coordinate down here, on X, I'm at 5. And on Y, I am at -12. So that's my coordinate. I can now substitute all of this into the Pythagorean theorem. And if I substitute it into the Pythagorean theorem, I can figure out how far it is in direct distance. So if I were looking at it, I'm going to start out with my square root, subtract my 2 x's. So it's going to be 5 minus 0. Whoops. And then I'm going to square that. I'm going to add to it -12 minus 0. And I'm going to square that. Okay, so I know by doing the operation, this is going to be 5 squared, which is 25. This is going to be -12 squared, which is 144. If I add those two together, I get 169. And the square root of 169 happens to be 13. So I know this distance from here to here is going to be 13 miles. As opposed to driving on the outside, which is 21 miles, if we had a helicopter, it would only be 13 miles. We can also use the distance formula in proofs. They tell me that ABCD is an isosceles trapezoid, and they want me to prove that the diagonals of ABCD are congruent. So what I did is I took my isosceles trapezoid and I put it in a convenient place on the coordinate plane. I decided to make my base 8 across, and my second base I decided to make 4 across. So the length on this one is 4, the length on this one is 8. I know these two are the same because it had the distances between the two would be the same. Now what I want to prove though is I want to prove that this distance is equal to this distance. So what I'm going to do is I'm going to use the distance formula. The first thing, I always like to include my given first. What they gave me is that ABCD is an isosceles trapezoid. After I do that, I find the length of my two diagonals. Diagonal AC, I substituted in my 2 x's and my 2 y's. And whenever I did that, this was 6 and this was 3. 36 plus 9 is 45. So I used the distance formula to show that the distance from A to C is the square root of 45. I did the same thing for DB. 2 minus -4 is still 6. 3 minus 0 is 3, so I added those together and I got the square root of 45. Okay. I can now say that DB is congruent to AC, which is the definition of congruence. So I've used these coordinates on the coordinate plane and the idea of convenient locations that we talked about yesterday in section 4 to be able to prove that the diagonals are congruent. Okay, this concludes the video on section 11.5, the distance formula. Remember, now that you've finished the video, you do still have some homework to do on page 679, problems 1 through 7.